Okay, we are asked to simplify the radical. So first of all, the square root of 4 is 2. Now for the variables. Since this is a square root, we know the index is a 2. So 2 cannot go into 1. So the x is going to stay inside the radical. But 2 goes into 12 6 times. And that is our final answer. Okay, here we're going to take the cube root of -8, which is -2. And 3 goes into 3 once. We don't need to put an exponent of a 1. And then 3 goes into 5. 3 goes into 5 one time. And it would have 2 left over as the remainder. So we're going to take out just a y, and then we're going to have 2 left over. Alright, so the square root of 32 is not a perfect square. So we need to take a look at our list here. And we need to think of what number on our list goes into 32. So we could pick 4, and we could also pick 16. It doesn't matter which one. So let's say we picked 4. The square root of 4 times the square root of 8 is 32. And the square root of 4 is 2. Then we have to simplify square root of 8 because there is a number on our list over here that can go into 8. So we have square root of 4 times square root of 2. Square root of 4 is 2. So 2 times 2 is 4 radical 2. So we could also simplify it by starting with the 16. And it's larger, so it'll be a little bit quicker to solve doing this way. So the square root of 16 is 4, and then we just have 4 radical 2. So the larger the number is that you start with, then the simpler it is to simplify. Alright, here we have the square root of 400. So we're going to take a look at our list here and see what can go into 200. So 4 can go into 200, 25 can, but 100 can, and it's larger. So if I pick square root of 100 times square root of 2, square root of 100 is 10, so we get 10 radical 2. Okay, so we have to take the square root of 50 and find which number that is a perfect square here in our list can go into 50. So I'm going to go with 25. So square root of 25 times the square root of 2. So the square root of 25 is 5. So we get 5 radical 2. But this -3 here was being multiplied to the square root of 50. So we have to multiply it to the square root of 50. So -3 times 5 is -15 radical 2. Okay, now we have a cube root. So we need to look at our list of cube roots here that we can solve. And I know that 8 goes into 24. So I'm going to use the cube root of 8 times the cube root of 3. Well, the cube root of 8 is 2, so we get 2 times the cube root of 3. Alright, so now we have a fourth root. So we have to think of what number can go into 48 that we could find the fourth root of. So I know that 16 goes into 48. Three times. So what number 4 times equals 16? That would be 2. So we get 2 times the fourth root of 3. Keep in mind the other way to have solved this is if we make a factor tree, such as this. And we write up until we only have prime factors. And if we do it that way, since this is a fourth root, we're looking for a group of 4. So 1, 2, 3, 4. So that would make 16. 2 times 2 times 2 times 2 is 16. That's why we would take out the 2. And then we would just have this 3 left. So that's where this 3 came from. Alright, we're back at a cube root here. So the cube root of 54, there is not a perfect cube root of 54. So we have to take a look at our list over here and decide what number here goes into 54. So 27 can. So the cube root of 54, we can write it as the square root, or cube root of 27 times the cube root of 2. The cube root of 27 is 3, so we get 3 times the cube root of 2. But, as you could see, we already have this 2 here. So we get 6, cube root 2. Now let's go ahead and take care of the variables. 3 goes into 4 once, with a remainder of 1. So we're going to have an A, and then we're going to have, since there's 1 remainder, we're going to have an A left inside the radical. And then 3 goes into 9 3 times. So that would be our final answer. Oh, actually I forgot this 2 right here, so we have to include that 2 here. Alright, now that's our final answer.